homework is due on that test. So if you're missing like 3 or 4 homework assignments right now, and you're on a pattern of missing a couple of weeks, that's a lot to make up by next week to turn in on the day of the test. I don't know. But I can look really quick. I'll figure it out. I don't know, maybe like 4-ish. I don't know. Maybe 5. I don't remember if we spent 2 days. Yeah, we spent 2 days on complex numbers. But I think we have 5. Like today would be 6. 2 out of 5 is stated. That's still 40%. Okay, so yesterday we solved equations with roots in them, but they worked out really nice. They just had numbers, not x's outside. So when there's x's in there, it's going to get a little more complicated, not too much. Number 1 rule is get the radical by itself before you square both sides. All right? So, because if you try to square both sides right now, you have to FOIL that out, and that's a little bit ugly. So step 1 is always isolate the radical, or if there's more than one radical, at least isolate one radical. So I'm going to subtract that 3 over and get x minus 3. This is actually like I did this in Algebra 1 ECA lab, preparing them for the test. Like you've done this before, it's just been a while. Number 2 that we're going to do, you have it probably. Number 4 is out of control. Just let you know. Chloe's on a college visit. I'm recording the notes for her. She missed like the biggest day ever in calculus today, but she promised me she's going to watch the notes twice so that she can know what she's doing. It is her 3rd college visit. She's trying to make a decision. Don't you think she's going to feel weird when she's watching the notes and we're talking about her?
Oh yeah, hey, she hear it?
What?
Can she like hear it?
Yeah, like you watch it and you can hear what I'm saying as you watch it. So it's like you're in class still. You can't escape me. Sometimes when there's a sub, I'll record the notes for you and you still have to sit and listen to me, only I'm not here, but you just hear my voice and follow the examples. Right. See, this is, when I was in high school, I hated when there was a sub because it was just a wasted day. Like I was just doing busy work and I just was dumb. And so I would be excited to know that I still get to learn when there's a sub. So I'm a teacher. I like to learn. I would always like, sub today, that means we're doing nothing. What a waste of my time.
Did you really say that?
Mm-hmm. Right, so I did the easy part. When there is addition and subtraction over here and you're squaring that, that is not just x squared plus 9, right? You know that that means there's 2 of them, and you have to FOIL that out. So that's x squared minus 3x is minus 6x plus 9. And then look what we have, a lovely quadratic. Everything's quadratic, it always goes to it. So get it equal to 0. So I'm going to subtract 3x over. I'm going to subtract 1 over. Right? X squared minus 9x plus 8. So get the radical by itself. Square both sides. If it's a quadratic, get it equal to 0. Now you have choices. Factor, complete the square, quadratic formula. Again, like I said yesterday, I like to factor, especially when x squared doesn't have something in front of it. So I'm always going to try that first. But if you don't want to factor, complete the square, do the quadratic formula. But I think this works, right? What multiplies to give me 8 that adds to give me negative 9? Negative 8. Negative 1. So I get x equals 8, x equals 1. Here's where we have to be really careful to make sure that this works, because sometimes with square root problems, when you square both sides, this works. To solve this equation, we get 2 answers, but when you plug it back into where the square root was, it doesn't always make a true statement. So you don't have to show me that you're checking it, but you need to make sure you remember to check your answers. On my pre-cal test, they had a question just like this today, and one of them didn't work. When you plug 8 in there, what do you get? You get 3 plus 24 plus 1 is the square root of 25 equals that true? 3 plus 5 equals 8. So that definitely works. Does 1 work? 3 plus 1 is the square root of 4 equals 1. That doesn't work. The square root kind of throws that off. So that's what we call an extraneous solution. So you have to check your answers on those, all right? And I said that yesterday. When there's a letter outside the radical, oftentimes you're going to get an extraneous solution. Okay? Kind of, sort of, maybe okay with that? Ready for a crazy one? Let's go. Oh my goodness. Testing out for this file. Remember how I tested that all over? Okay, so this one has 2 radicals in it. You can't get rid of both at the same time, so you have to do this, like get rid of one and then get rid of another. But step 1 is get one of those radicals by itself. So I'm just going to get this one by itself. Are you okay with that? So I'm going to keep this square root of 2x minus 3 on this side, and I'm just going to move everything else to the other side. So I'm going to add that over, so that's going to become the square root of x plus 7, and I'm going to subtract the 2 over. So isolate one radical. And then just like we did on the last one, what are we going to do next? Square both sides. See where this is going to get a bit ugly. So this side is the easy part. 2x minus 3. We got to square this with the radical in it. So again, I'm going to write it twice. That's what squared means. And we got to kind of use our brains a little bit. What do I get when I take the square root of x plus 7 times the square root of x plus 7? Just x plus 7, right? The square root times itself just cancels out the square root. So I just get x plus 7. But if I FOIL, I have to take this times negative 2, which is just negative 2 square root of x plus 7. Then I have to take this times that again, which is negative 2 square root of x plus 7. And then negative 2 times negative 2 gives me a plus 4. So we're FOILing with the radical. How exciting. With me so far? Now we just need to kind of clean it up a little bit. So I could say x and then plus 7 and plus 4 would be plus 11. And I have 2, negative 2 square root of x plus 7, which gives me a negative 4 square root of x plus 7. What have we accomplished? We got rid of one square root. What's the problem? We still have another square root. So it's like starting over. What do I need to do if I want to get rid of a square root in a problem? Move everything else to the other side first, and then square both sides. So the reason these problems are awful is, 1, there's a lot of algebra going on, lots of room for error. But 2 is because you have to do this twice. You have to isolate a square root and square both sides 2 times. So I'm going to subtract x, and I'm going to subtract 11. Remember that sometimes people want to take 11 minus 4 here and get 7, but this negative 4 is stuck to that square root, right, because it's multiplication. So it's kind of its own little thing here. I'm going to write it right over here. So 2x minus x is just x. Negative 3 minus 11 is minus 14. And now I just have negative 4 times the square root of x plus 7. That was a lot better, right? 2 options. We could divide by negative 4 first. Or because it's only multiplication over there, we could just square both sides. It doesn't matter to me. My choice would be let's leave the -4 here because I don't want to deal with a fraction over here. But it's up to you. If you want to move it over, you can. Multiplication, we're allowed to just square it and square each thing. Right? You just square the -4 and you square the x plus 7. If you want to divide it, if it makes you feel better, we could do that. So over here, I get x squared minus 14, and minus 14 is minus 28x plus, what's 14 squared? And on this side, -4 squared is just 16, and the square root of x plus 7 is just x plus 7. We're not done yet, but we're in the home stretch. We got rid of both square roots. We have a quadratic here. I think we need to distribute our 16. I don't know what 16 is. 112. So I'm going to subtract 16x, and I'm going to subtract 112, and I'm going to hope it's factorable because I sure don't want to do the quadratic formula at this point. But who knows? 44, is that true? 28, -28 and -16 make -44. Is that true? That's a lot of work, right? I'm going to try to come up with things that multiply to give me 84, then subtract to give me 44, add to give me 44. 42 times 2 gives me 84, and if I make them both negative, that'll give me -44. So after all this hard work, we get x equals 42 and x equals 2. But we have to check our answers still, right? I'm guessing one of them doesn't work. Wouldn't it be really awful if neither one of them worked and did all this work and the answer was no solution? That'd be terrible. Alright, now I gotta go back up. Can I go back up or are you still writing? Alright, 42 and 2. You gotta remember that. 42 and 2. Let's do 2 first, it's easiest. If I plug 2 in there, I get 4 minus 3, which is just 1. And if I plug 2 in there, I get the square root of 9, which is 3 plus 2 equals 0. Is that true? 1 minus 3 plus 2 equals 0. 3 minus 3 equals 0. True. X equals 2 works. If I plug 42 in there, 42 times 2 is 84. 84 minus 3 is the square root of 81, which is 9. Okay? Minus, if I plug 42 plus 7, I get 49. Plus 2 equals 0. So x equals 2 is the only one that works. I think I only put 1 in the homework. Maybe I put 2 because I knew you were going to ask me 1 and then there's something to do. I don't know. But I think I'll put 1. Okay. What else do I have? More stuff. What time did we get out of here today? 42. I think this is better than the other ones, maybe. Do you remember U substitution from Algebra 2?
Yeah.
So U substitution is if it looks like a quadratic, if it's quadratic form, then you can still do the quadratic formula, even though this is a degree 4 function, right? So quadratic form is if you have, like, think about what we have, ax squared plus bx plus c. So if your last term is a constant, if your middle exponent is half of the leading exponent, then that's quadratic form. So x to the fourth, x squared, no x, fits that same format, so we say that we can do quadratic form. You can do u substitution, or you can kind of just work it out the same way. If you did u substitution here, what would your u be? Yeah, and u should always be, if it fits quadratic form, u will always be that middle term. Like normally in the quadratic formula, we say x equals, or we factor it out as x and x, because that's the middle term. So your u will always be that middle term. So if you want, you can rewrite this as u squared, because u squared would be x to the fourth, minus 3u plus 1. And now that looks just like a quadratic. If you want to just leave it as x to the fourth, I'll kind of do that at the same time and show you that it's whichever way works for you. I don't really like you most of the time. Get it? It's a joke. I usually do it without u substitution, and I'm going to show you what I mean by that. But I'm okay whichever way. Like most people feel better about it. But I'm going to do the same thing over here without you. And show you that we'll get the same answer. You have to remember on u substitution, I don't care what u is, I want to know what x is, so you have to go back, right? This is not factorable, yes? So we have to complete the square or do the quadratic formula. Which one do you want to do? Quadratic. Complete the square with a fraction? Okay. All right. So quadratic formula is x equals negative b, but now we have u equals negative b plus or minus the square root of b squared, be 9, minus 4 times 1 times 1, all over 2 times a. Right? So a, b, and c are the same. That works out really nice. 9 minus 4. Okay, it's not really nice, but I can do it in my head. 9 minus 4 is just 5. The square root of 5 is not a perfect square, so we just leave it alone. All over 2. If that was x, we would be done, right? X would equal this and we're done. But that's what u equals. So you have to remember to go back and plug back in what u was. So u is x squared. So you have to go back and say that x squared equals 3 plus or minus the square root of 5 all over 2. Gross. No, that's what x squared equals. What does x equal? Plus or minus the square root of that ugliness? And there's not really a great way to write that. But we would take the square root of this, and we would say x equals plus or minus the square root of 3 plus or minus the square root of 5 all over 2. How many answers are there? 4. Because the plus or minus makes 2, and then plus or minus under the radical makes 2 more. And you could plug that in your calculator and get the decimal for each one. We could talk about trying to simplify it better, but like I'm okay that if it works out ugly like that could be your answer. You would get the same thing here if you recognize what u would have to be. Instead of doing u substitution, you could just say the middle number, x squared equals, and you do the quadratic formula, and then you'd still have to take the square root. People like u substitution because it kind of makes it look like we've always seen it, but you don't necessarily have to do it. It's much easier to not do u when you the factors. All right, what if I gave you this with fractions? Can we do that? I got one example here. We're going to try to do it, all right? So this is our final answer here. What if I gave you this? So you can't do the factor thing like we did yesterday because they all don't have an x in them. So you can't factor out an x to the 1/3. This fits the quadratic form, okay? If I have x squared plus bx plus c. If if you double that x on the exponent, does it equal this one, right? Like if you doubled 1/3, do you get 2/3? Right? So if you double the exponent here, you should get the leading one. That fits quadratic form. So 2 ways to do this. Fractions freak you out, right? Change it to u's. Your u should always be that middle number, or that middle letter. So if u is x to the 1/3, what does x to the 2/3 become? If you square this, does it equal x to the 2/3? If I square that, does it equal 2/3? Yes, yes. So this becomes u squared plus u minus 6. Is that factorable? Oh my gosh, it is. 3 times 2 gives me 6. And if I do plus and minus, I get u equals -3 and u equals 2. Do I want to know what u is? I don't care what u is. I have way too much fun with u substitution. I want to know what x is. So you have to go back and you have to substitute back in what you called u, right? So you have to say if u equals -3, that means x to the 1/3 equals -3. And that means x to the 1/3 equals 2. The u is just a step to help you. What do I do to both sides to get rid of the 1/3 power? Take it to the 3rd power, right? Take it to the 3/1 power. And I get x equals -27 and x equals 8. I don't think so. I mean, we could check it, but I don't think we have to because it's the 3rd power, right? The whole plus or minus stuff goes off. But I think it's okay. No, well, it's all weird with numbers, right? Like with exponents, like what's the degree of that? You can't really use the fundamental theorem of algebra with rational exponents because it's not a polynomial. Like that doesn't fit the rule of the degree equals the number of zeros. Does that make sense? Okay, let's see what homework I gave you, so in case I gave you too many. 1922 is the good one. 24 is not bad. 30, the last 3 are the u substitution, the first 3 are the square root. One of those is the big one. Try that tomorrow. Actually, I'm going to tell you number 22 is the big one. Before I do that on the board tomorrow, I'm going to look at your papers and see that you have attempted that, or you have to go out of the room while I do it. Yes. Try it. Before it doesn't help if you don't try it. I can stand up here and do them all day, right? That doesn't help you. Try it. Do your homework.